Hello and welcome to Microsoft Fabric Training 2023, and this is part of the entire training module for Microsoft Fabric that includes Power BI, Data Warehouse, Data Lake, and other Data Studio as well. In this module, we will cover data science in Microsoft Fabric and how efficiently we can create different, insights and combinations uh, to perform data science operations and analyze the data to identify complex pattern, which will provide the end results uh, to the benefit as well. So let's get started. First, we'll cover some theoretical aspect of what science is, and what needs to be done for the analysis of the data that is there using Microsoft Fabric. Imagine you are working for a supermarket and you want to know how much bread you need. um, in order to have stock every week and meet the customer demand and avoid food waste. The other aspect is that if you want to analyze customer and how best we can target them with personalized offers. So whenever you want to make informed decision within an organization, you can use data science to get insights from the data you have. And data science is a combination of mathematics, statistics, and computer engineering. So when you perform the data science operations, you can analyze the data by identifying complex pattern, and that can provide you meaningful insights as well for your organization. You can use data science to create artificial intelligence models that encompasses of the complex pattern that you find in the data. One common approach is to use data science to train machine learning models using libraries like scikit and learn python to achieve AI. And we can have a broader sense of achievement in terms of using python and uh, other machine learning methodologies as well. So Microsoft Fabric provides a comfort level in providing in addressing the challenge that which will be created once you have a complex large data. So it provides a end-to-end data science project methodology as well. This structure provide an efficient way to find insights and pattern from textual and structured data. Moreover, the Custo query language, which we have studied in the previous modules, is optimized for data that includes time series components such as real-time data, log files, and streaming services. With real-time analytics, you can focus on and scale up your analytical solution while arranging, spreading out the data from the needs of your entire organization. So this is what the data science methodology is, and you can use modern Microsoft Fabric to use and to create the solution. Let's go on and discuss about what is the actual data science process. Um, because the purpose of machine learning is to train modules uh, and models that can identify pattern in large amount of data. You can then use the pattern to make predictions that provide you a new insight on which you can take actions. The possibility with machine learning may appear endless. So let's begin with understanding the four common types of machine learning models. The first one is the data classification. The second one is regression. The third one is clustering. The fourth one is forecasting. So what we are doing in classification is we are predicting the categorical value, like whether a customer may churn or not. So this is we are dividing non-churn customer with the churn customer details. Regression is predicting a numerical value like a price of a product for future analysis and stuff. Clustering is grouping similar data points into cluster or group. And finally, forecasting is predicting future numerical values based on time series data like expected sales for the coming months. So, in order to decide which type of machine learning model you need to train, you first need to understand the business problem and the data available to you. So whichever model you create and you identify, there are five common steps that we uh, we go through. First is the definition of the problem, then we gather the data, then prepare the data, we train the model, we then generate insights from them. So definition of problem is that, with the business user, we can decide what the model should predict and when it is successful. Um, Getting the data is just finding the data source and getting access to storing the data in the lake house. Um, Number three is preparing the data, and then we are exploring and reading the data from the notebook or from the lake house to the notebook, and we'll just clean and trim and transform the data based on the model requirement. We then train the model, choose an algorithm or a parameter value based on trial and error by tracking your experiment in the machine learning flow. The last part is generating insights, and use the model to batch scoring and generate requested predictions. As a data scientist, most of your time is spent on preparing the data and training the model. How you prepare the data and which algorithm you choose to train a model can influence your model success. You can prepare and train a model by using open source library available for the language of your choice. For example, if you work with Python, you can prepare the data with pandas and NumPy and train the model with libraries like scikit, learn, and pytorch and synapse machine learning. When experimenting, you want to keep an overview of all the different models you've trained. You want to understand how your choices influence by the model's success. By tracking your experiment with ML Flow in Microsoft Fabric, you are able to easily manage and deploy the models you have trained. So, following everything in Microsoft Fabric, you will be able to have a complete control on what you will be needing. The data itself is the cornerstone of data science, but particularly when aiming to train the machine learning model for achieving artificial intelligence, typically model exhibit enhanced performance as training data set size increases. In addition to the quantity of data, the quality of the data is equally crucial. So we need to ensure that we ingest the data in Microsoft Fabric in a cleaner way and in a crucial way as well. So, ingesting your data, Microsoft Fabric provides a robust data ingestion process engines to make sure that we have a correct quantity as well as the quality of the data as well. And you have the flexibility to opt for either a low code or code first approach when establishing the essential data ingestion process. We will be creating a pipeline for the data ingestion, or we will be manually connecting with the connectors to ingest the data inside. So what we are doing is we are ingesting the data using Microsoft Fabric, and everything will be under Fabric's umbrella. The next step would be to explore and transform your data. And this is true as a data scientist, you may be most familiar with writing and executing codes in Notebook, particularly in Python, Windows, VS Code, and other machine learning. Even Azure Data Studio provides a notebook environment, or does your ML compute instance provide a notebook environment to execute Python code with libraries and different stuff. Microsoft Fabric also provides a similar notebook experience powered by Spark Compute, and this is Apache Spark, which is an open source parallel processing framework for large scale data processing and analytics. So, in order to explore and transform data and help you explore and transform more quickly, Microsoft Fabric offers the easy to use data wrangler, which is called which after launching the data wrangler, you get a descriptive overview of the data you're working with. You can view the summary statistics and find any issues like missing value, cleaning the data, and even apply auto build data cleaning operations. When you select an operation, a preview of the result will automatically be generated for you. When you have selected all necessary operations, you can export the transformation to code and execute it on the data. So this is the flexibility that the data wrangler in Microsoft Fabric gives to you. Next, we'll move on to train and score model with Microsoft Fabric. So the next slide would be to, how we will be training the model and how we'll be exploring and doing performing some operations. So basically, once you have ingested, explored, and pre-processed your data, you can use the data to train a model. Training a model is an iterative process, and you want to be able to track your work. Microsoft Fabric integrates with MLflow to easily track and log your work, enabling you to review your work at any time to decide what the best approach is to train the final model. When you track your work, your results are easily reproducible. Any work you want to track can be any work you want to track can be tracked as experiments. So this is experiment. An experiment, whenever you train a model in a notebook that you want to track, you create an experiment in Microsoft Fabric. An experiment can consist of multiple runs. Each run represent a task to you executed in the notebook, like training a machine learning model. For example, to train a machine learning model for sales forecasting, you can try different training data sets with same algorithm. Each time you train a model with different datasets, you create a new experiment run. Then you can compare the experiment run to determine the best performing model. By tracking your work with MLflow, you can compare model training iterations and decide which configuration and which is the best model you can use. So this is the experiment and starting to track the metrics. Then we can understand what we go to understand what the model is, because after you train a model, you want to use it for scoring. With scoring, you can use the model on new data to generate predictions or insights. When you train and track a model with MLflow, artifacts are stored within the experiment run to represent your model and its metadata. You can save these artifacts in Microsoft Fabric as a model. By saving your model artifacts as a registered model in Microsoft Fabric, you can easily manage your models. Anytime you train a new model and save it under same name, you add a new version to the model. So basically, it's going through the version controls and all the stuff as well. And then once the model is trained, model is generated and stored, we will use the model to generate insights. To use a model for generating predictions, you can use uh, a function called predict in Microsoft Fabric. The predict function will is kind of a built to easy integrate with MLflow models and allows you to model for generating batch predictions. Let's take an example. Every week you receive a sales data from several stores. Based on historical data, you train a model that can predict the sales for the next week. Based on the sales of the last few weeks, you track the model with MLflow and save it in Microsoft Fabric. Whenever new weekly sales data comes in, you use the predict function to let model generate the forecast for the next week. The forecast sale data is stored as a table in the lakehouse, which can be visualized in Power BI report for business users to consume. So this is basically what we will do. We'll just create an experiment, and then we train the model, and then after the model is trained, we use the predict function to predict what it is. And we'll move on to the exercise, and then we will perform all the operations that are related to data science in Microsoft Fabric. So after a bit of a theory about data science and how we can use Microsoft Fabric using data wrangler to train and experiment the model and as well as predict the model using this, now we'll move to the practical aspect of it. And what we will do is we'll just ingest the data, explore the data in the notebook, and process the data with the data wrangler, and train two types of models by performing the relevant step to explore the data, ingest the data, transform the data, and then predict the data as well. So in this approach, what we will do is we will get a hands-on experience in machine learning, model tracking, and then how to work with the notebooks, data wrangler, experiments, and models. So in the previous video, if you're not following along, in the previous video, we've created a test fabric workspace, and we have done all uh, the lake house as well as ingestion process for the other aspect. If you want to follow along, then look for the training modules related to Microsoft Fabric within my channel. So we'll start off with a data science mode in Fabric. So we'll just click on this bottom left and then go to data science, and it will load a data science homepage. In that homepage, we have a machine learning model, experiment, notebook, environment, and we can import the notebook as well as use the sample. So in the Synapse data science, what we'll do is we'll click on notebook. We'll just select the sensitivity label as internal, saving and continue, and after a few seconds, a notebook containing a single cell will open. These notebooks are made up of one or more cells that can contain a code as well as the markdown or formatted text. What we will do is we'll select the first cell, which is currently a code cell. So we'll click on M arrow here. So it will be a markdown mode. So what we will do is now is we will click on edit button and then just type data science for in MS Fabric. Okay, there you go. So this is data science in Microsoft Fabric. This is the heading, and then what we'll do is we'll just click on plus code. This will open up the code using the Python PySpark um, coding language. We can use other language as well. It is mentioned in the previous videos if you want to refer. So what we will do is we will use a sample data set and sample database that is in Azure or open data set. So I will paste the file in the comment section for if for your help. But in this aspect, what we'll do is we'll use the diabetes data set where we need to have an access to. So let me copy paste this one. So I'm just copy pasting the account name as well as the samples as well as the relative path related to that, and we'll just try to run this up and we'll see how it is executed. So this is starting off the engine, the session is starting, and the session has been started. And then after after few time, it will be executed. So there you go. It has been executed successfully. So now what we'll do is we'll just uh, add another piece of code. I'm just splitting the entire text to a different code um, cell so that we can have a clarity in that. So here we defined all the variables related to the machine learning samples, and it is the diabetes data that we are getting. um, then we will be getting a path for the uh, remote path for the data set, and then we are just configuring the blob storage, and we will just try to execute this and then see the it is executing the sample data set in the sense. So now what we will do is we'll add another code. In that another code, we will just define a data set to read the Parquet file for this path. So now we are executing this path. Okay, there you go, it's running. So this has been executed. So all three sections has been successfully executed. I'm adding another code, and then I'm using the Python Python language thing to display the data frame. So we have stored this in the data frame. We're just trying to execute this, and this is running and displaying the data set. So this has successfully added the diabetes data set, sample data set in the in the data frame. So this is displayed as a table. We can also display it as a chart for each of the element. We can customize. We can do some different aspect to create something. So for example, we have changed box plot, and we'll just remain leave the key as it is, and the value as age. We'll keep it as it is, the value as y, and then we'll see apply. So it is showing as, sorry, a box plot is connected. So this is showing as a range of percentage, and it's just box and whisker chart. So it is showing as. So now we have done a basic exploration of the data, and you can see this: the age maximum 79, minimum 19, the upper quartile is 59, median is 50, lower quartile. You can do a BMI as well for that, and this is generating a box and whisker with the upper limit as 42.2, while the minimum is 18 onwards. So this is a good exploration in terms of the centralized data as well as the box plot related to that. Now what we'll do is, we have ingested and explored the data. We can now transform the data. Um, we can run the code in the notepad by adding plus code, or use the data wrangler to execute and to generate the code. But in order to generate the data wrangler, you need to convert the data to pandas data frame. So what we'll do is we'll just use the existing data frame df df2 pandas, and there you go, df dot head. So just to check, the shortcut method to execute a code is control and enter. So this will run and execute the code. There you go. So we've converted this to pandas, and we've used the header to see the executable language. So in order to launch the data wrangler, we just click on the data tab in the ribbon, and then click on launch data wrangler. So we'll just select the data frame, and the data language is when the data wrangler is launched, it generates a descriptive overview of the data frame in the summary panel. So this is summary panel, like it has 442 rows, 11 columns. There are some duplicate rows, duplicate missing values. And this is just giving a summary of it, and this is basically exploring the data itself about how we are showing as a distinct value or some missing value. So this is basically an enhanced version of the Power BI Power Query mode of the column exploration. So in this data, the label column is y, which is a continuous variable, and to train the machine learning model that predicts y, you need to train a regression model. The predictive value of my y may be difficult to interpret. Instead, we could explore training a classification model which predicts whether someone is low risk, high risk, or developing diabetes. So to be able to train this classification model, you need to create a binary label column based on the values from y. So what we'll do is we'll just select y in the data wrangler, and it has giving a complete statistics of that column. As you can see, this is not a normal distribution. It is just skewed towards the minimum percentile. The 75th percentile is 211.5, which roughly aligns with the transition of the two regions in the histogram. And let us use this value as a threshold for lower and higher risk. So what we'll do now is we will navigate to the operation tab, and then under the formula, we will create column from formula. We'll just give this column name as risk, and then use the formula as df y greater than 211 211.5 dot as type int. So while you type this up, it has been added as a preview, and it is showing as some sort of a distinct value, which is the uh, above the 75th percentile of this. We'll just click and apply, and you remember it has just created a column and added a step as well. So this is df risk is equal to dfy greater than 211.5 as type int. So this is showing up as steps as well. Now we'll select, after creating this, we'll select add code to notebook. And this is, if you see, it has been generated by the data wrangler to create a code. We'll just execute this code. And if you see here, the risk column is added based on the Y. So this df underscore clean, we will just check and describe and execute. And this is showing as 4 values with the mean as 0.25 and onwards. The maximum value is 1 and the minimum is 0. Now that we have prepared the data, we can use it to train a machine learning model to predict diabetes. We can train two different type of models with our data set. One is the regression model, which is predicting Y, or a second one is a classification model, which is predicting risk. You'll train the model using the scikit-learn library and track the models in MLflow. So we'll add another code snippet. I'll share the snippet in the comment section. So for this one, what we are doing is we are just executing the code. Let's execute this. What is it doing is just importing the training model from sklearn, scikit-learn, and we are just putting it some values to train the model with the test size. This has been executed. We'll add another code snippet. This will import the ML flow as well as the experiment name, and then we'll just give the experiment name as the diabetes dash regression. So all the models will be tracked under this experiments. So this is executed. Now we'll add another code that will start to run and use the uh, regression model using linear regression, and then parameter using the parameter matrices and artifacts which are automatically logged in the ML flow. Now we'll add another code that will split the data into training and test data set, and to separate the features of from the label risk you want to predict. So this is just separating the training and test data set, and using the same approach. So previous one was regression. This one is classification. So now we've got two experiments, and then we will just find out um, the classification versus regression model. We'll add another code snippet, and this in this code snippet that is a train. This trains a classification model using logistic regression, with the parameters and everything is automatically logged. So previously it was a regression, and previously it was using linear regression. This one is using the logistic regression. So once we are done with the experiment, we can explore the experiments. We can do this by going to the workspace actually. Once this experiment is loaded and executed, it runs a kind of a list that takes some time to execute, and it will create some experiments in the workspace itself. So if we go to the testing workspace, the actual workspace, we can see two experiments here: the diabetes regression and the diabetes classification. So this means that they are being created in the workspace itself to view and visible. So let's click on diabetes regression, and it is just loading the experiment. So if you don't see this very after just running the experiment, if you don't see this, then you have to wait, because there is some process that executes and creates the file of the experiment status. So this is showing up all the details about the run metrics, the absolute error, the squared error, as well as the training score and all the stuff. So, and then we can just go back again to the workspace and open up the diabetes classification. And this is also having the accuracy score and all the stuff, so we can review both the models and see how it goes. And then we can see which numbers are are relevant, so that we can add it to the and save it as a model. So after comparing machine learning models that you have trained across the experiments, in this case two experiments, you can choose the best performing model, and use the best performing model to save it as a model itself. So what you can do is you can just select save in the save as model you know dialog box. It will open up the
thing, the dialog box, you can select the folder as model, and we can name the model as model die model name. Make sure you don't have space, because it should be either hyphen or underscore diabetes, and then we will select save. It will always ask for the sensitivity label. We just save as a model, so it will just save as a model, and then can it will take some time to load. So once we have the model created or saved, it will have a notification that says we can view the model. So once we click on view the model, it will open up the versions of the model, as well as the other aspects of the file as well, like ml model, yml file, and other things as well. So now that you have finished training and evaluating the model, you can save the notebook with a meaningful name and end the Spark session. So we can go to the menu, and then we can click on settings, and this will have, we'll just rename to train models. And that's it. We are done with the full data science exploration, where we have loaded the data. We have just explored everything, and we have saved it to the pandas, and then we have created a model based on the ml flow. We've used some regression as well as classification. We've also done a data wrangler transformation, and then saved it to the the notebook itself, and then we have created and executed two models. One is the diabetes linear, one is using the linear regression, the other one is using the logistic regression. And then we viewed the model itself, and we've also viewed the diabetes calculation and the scores as well, so that we can fetch up all the scores, and we can go to the model, and every time we execute, we run the model, and we can explore all the things together. Thanks for watching, and I will see you in the next video.